Hello, this is lecture 6 of Chem 111, Organic Chemistry 1. I'm Patrick Willoughby. Last time we looked at counting neutrons and how changing the number of neutrons within an atom affected its properties. Today we're going to look at how changing the number of electrons affects the properties of an atom. So, get my notes up in front of you all. Okay, so the first thing we want to recognize is that atoms do have charge. It's kind of a weird place to put the word do, but for example, we'll get to why atoms do have charge in a second. But for example, we could say that atoms have a charge of +1 or -1 or even -3 or +5, for example. But atoms can also have the charge of 0. If we have a 0 charged element, then we have a neutral element. And a neutral element arises from an atom that has a balance of protons and electrons. I'll remind us that my P+ is an abbreviation for protons, and my E- is my abbreviation for electrons. Okay, so a neutral element has a balance of protons and electrons. And so, for example, if we look at carbon 12, and I say that it has a 0 or neutral charge associated with it, I could then ask a question. For carbon 12 with a 0 or neutral charge, how many protons, neutrons, which I show as N0, and electrons are in this element? Or instead of in, we could say, does this element have? Okay, so first of all, the number of protons can be determined by the element. Carbon always has 6 protons. Okay, so step 1 is complete. For the number of neutrons, that's determined by the atomic mass. So atomic mass equals 12. How do I know that? Well, in my name for the atom, I called it carbon 12. So with an atomic mass of 12, what we do is we take 12 and we figure out the number of neutrons. 12 is equal to the number of protons plus the number of neutrons. Why? Because the atomic mass is always equal to the number of protons and the number of neutrons, because each of those subatomic particles, protons and neutrons, each weigh 1 AMU. So 12 is equal to the number of protons plus the number of neutrons, and if 12 then is equal to 6 plus the number of neutrons, when we substitute in the number of protons that we solved in the first part, then the number of neutrons must equal 6, right? Because 12 minus 6 is 6. Okay, so the number of neutrons is 6. The number of protons is 6. But how about the number of electrons? This is determined by the charge of the atom or element that we're looking at. And I should call that an atom. Determined, and we should have the word by in there. So this is determined by the atom's charge. Okay, so charge, we said before, was 0 or neutral. 0 or neutral charge. I'm going to change the page. The charge is equal to the number of protons minus the number of electrons. Okay, that seems to be, that seems to be true for most cases here. I mean, really all cases. But if you want to think more formally why this is the case, it's actually the charge of the proton times the number of protons plus, then we take the charge of the electron times the number of electrons. So we add those two things together and we get the overall atomic charge. Okay, now that is a little bit of a complicated notation, but just recall, and I'll just kind of change the color here, go with red. The charge of the proton is +1. The charge of the electron is -1. So that all simplifies out into the equation that I've kind of shown up here, where we see the number of protons minus the number of electrons, where this negative sign comes from the fact that electrons have a charge of -1. Okay, so that's where our little handy equation comes from. But we can solve this now. If our charge is equal to the number of protons minus the number of electrons, we can figure out the number of electrons using simple algebra. That is, for our case, we have a neutral or 0th charged atom, and we have 6 protons, and we have to subtract the number of electrons. The number of electrons, then, from 6 to get 0, which tells us that our number of electrons is equal to 6, right? If you subtract both sides by 6, divide by -1, you get an answer of 6. So just to recap, carbon 12 with a 0 charge has 6 protons, 6 neutrons, and 6 electrons. And we figured out general ways to solve this that can be used for really any atom. What I want to do now is move into situations where atoms have an imbalance of protons and electrons. And these are called ions. Ions are atoms with an imbalance of protons and electrons. And as a result, the overall atomic charge is not equal to 0. Okay? So what are some I'm going to use the word likely instead of possible. What are some likely ionic charges? And that's just another way of saying charges of atoms, where we don't have a 0th charge. So some charges of ions that we are likely to encounter would be -1, +1, +2, -2, etc. What about like -450? You know, that's not likely to be the case. Okay, and really even like upwards of -45. I don't even think there aren't even elements that have over 150 protons that we've been able to synthesize. So even within kind of the realm of the periodic table that we could consider practical, like for example, element 45 is rhodium. We're not going to see a charge of like -45 or +45. Okay, that's not going to happen. It's really going to be like -1, +2. that sort of thing. So kind of these lower numbers, either plus or minus. Okay, so how could each of these types of charged states result? How could each ionic charge result? What we would need for positive charges to form is we would need more protons than electrons. More protons than electrons. Now, positive charges, whenever we have ions that are positively charged, we call them cation ions, and that's an important term. So cation ions are a class of ions or a class of non-zero charged atoms that have more protons than electrons. Now, it's not a cation, like a vacation, for example. It's a cation. I should write that in here. Cation. Okay? So positive charges result when there are more protons than electrons. Negative charges result when there are more electrons than protons. Here it's the opposite. We've shifted the balance so that we have more electrons, more of these negatively charged particles in our atom. And as a result, the overall atomic charge is going to be negative. We call negatively charged ions anions. So whenever there's a shift in the balance of protons and electrons such that there are more electrons than protons, those are ions that are classified as anions. So anions and cations are examples, or really the two types of ions. Okay, let's look at a few examples of these before we end the lecture. Let's look at nitrogen 14 with a +1 charge. Oh, nitron, excuse me. Nitrogen 14 with a +1 charge. So nitrogen, according to our periodic table, is element 7. It has an atomic number of 7, which means it has 7 protons. Now we could do either the neutrons or the electrons next. I'll stick with the neutrons. So the atomic mass equals 14. Why? Because I said it equaled 14 in my definition of the atom, just the example that I provided for you. So the atomic mass of 14, and that's equal then to the number of protons plus the number of neutrons. So we have 7 neutrons. Okay, so changing the page. With a +1 charge, we recall that our charge equals the number of protons minus the number of electrons. So if we have a +1 charge and we have 7 protons, which was described previously, we basically solve for x, where x is the number of our electrons. So what I'll do is I'll minus 7 from both sides. Okay, so that's going to give me a -6 is equal to negative number of electrons. I'm going to divide both sides by -1 to cancel out my minus sign in front of my electrons. And excuse me, small typo here, -6. Okay. Now -6 minus 1, that tells us that we have +6 equals the number of electrons. And the number of any subatomic particle should be a positive number because you can't have negative subatomic particles. So the number of electrons is equal to 6. Notice that with a +1 charge, which is, to remind us all, a cation, with a +1 charge, which is a cation, we should have more, what do we have more of? Protons than electrons. We have more of the positively charged subatomic particles than the negatively charged subatomic particles. And the answer to our question was 7 protons, 7 neutrons, and 6 electrons. So that's consistent with our saying that cations should have more protons than electrons. Okay, before we go on to an anionic example, an example of an anion, let's go ahead and just kind of introduce new notation. I'm going to call this alternative notation. So alternative notation for ions. What we could do is we could have the atomic symbol, and I'm going to pick on the example we just looked at. So nitrogen 14 with a 0th charge. So I'm going to call that molecule 14 superscripted, N normal, 0 superscripted. Now this is an alternative notation, and what this shows is the atomic mass up and to the left, and then the charge up and to the right. And then if we needed it, which we don't in this case, this would be the number of these atoms, which is 1. For our exercises that we're looking at, we're probably just going to, when we're counting numbers of protons, neutrons, and electrons, it makes more sense just to stick with one atom, one example of this element. Okay, so in our earlier example, and excuse me, very sorry, we just looked at nitrogen with a +1 charge. I am very sorry. So we put the charge up and to the right, and then the atomic mass up and to the left. In our earlier example, where we did have a neutral element, we would have carbon 12 up and to the left, 0 up and to the right. So our charge, very sorry about that, +1 in our earlier case. Just to make sure we're crystal clear, we have an atomic mass of 12, and we have a charge of 0. Okay, let's do an example of an anion before we break. So an anion that we could pick would be O16 minus 2, and maybe I should start introducing some isotopes. So we'll cross-pollinate some ideas. We'll have isotopes of more abundant elements along with charged species. So I have this element, and again, the question is, how about the number of protons, neutrons, and electrons? Okay, I also have listed this, or written this, excuse me, in the new format. So 17, that's the atomic mass. -2, that's the charge. In this case, we're looking at an anion because it has a negative charge. Negatively charged ions are anions. Okay, so let's start with the number of protons. The number of protons, well, for oxygen, we look at our periodic table, the atomic number is 8. And this 8 comes from the periodic table atomic number. Okay, so 8 protons for oxygen. Now the number of neutrons is equal to 17, which is the atomic mass, setting 17 equal to 8 plus the number of neutrons. Now, if we solve this, instead of having an equal amount of neutrons and protons, the number of neutrons in this case is equal to 9. Okay, the number of electrons, so we are 2/3 the way done, the number of electrons. What we do is we set the overall charge, which is 2 in this case, overall charge is set equal to the number of protons minus the number of electrons, which is equal to 8 minus the number of electrons. So in this case, -2 minus 8 is equal to -10 divided by -1 is equal to the number of electrons, which is equal to 10. We have 2 more electrons than protons, and so we have an overall charge of -2. If you find an easier way to solve that, go ahead and use it. But these are just kind of things that I use that work all the time. Okay, so that's it for this lecture. We looked at, just to recap, we looked at counting electrons within atoms and examples of various atoms with various charges, and kind of looking at not only the number of electrons they have, but also the number of protons. The skill of counting the number of protons, neutrons, and electrons within a given element with a given atomic mass and a charge is an important skill and something that will appear on exam 1.